Okay, let us understand the expansion of determinant of order 3 cross 3. Given the matrix as this one, this is of order 3 cross 3, and we have to find the determinant of this matrix. Let us find this one. Okay, for there is a proper working rule for finding the determinant of this matrix. So we need to understand that working rule. So what is the working rule? Determinant of A. Now, how a determinant is expanded of 3 cross 3 order? We take any row or any column. Okay, if you take any row, any column, the expansion will be same. The answer, the result will be same. Okay, so what we are doing, we are taking the first row and will verify with any of the row and column, the answer will come same. Okay, let us take the first row. Okay, we are taking this first row. Now this 3, we are writing here 3 determinant. Okay, if you are taking this 3, that means you have to skip this row, this full row, and this full column. You are left with 1 3 3 9. Okay, so 1 3 3 9. Okay, then you have to use minus sign, and then the next comes 1, so 1. Then determinant, for this one, what you have to do, you have to skip this row and now this column. Okay, so you're left with 2 3 4 9. So write 2 3 4 9 plus 0 0. Then again, what you have to do, you have to skip this row, this column, 2 1 4 3. So 2 1 4 3. Now why this plus minus plus? This is the working rule. Okay, this is the working rule. Okay, you have to remember that for this one, plus minus plus, this goes alternatively. Okay, okay, so let us find the value of this one. Now in the uh, previous video, we have seen how to expand this 2 cross 2 determinant. Okay, let us follow the same. 3 9 ones are 9, minus 3 threes are 9, minus 1 bracket, 9 twos are 18, 4 threes are 12, plus 0 times 3 twos are 6, minus 4 ones are 4. Okay, 3 into this will give you 0. 18 minus 12, 6, plus 0. This is total 0. So your final answer is what? Minus 6. So this is how we find the expansion or the determinant value of this 3 cross 3 matrix. Okay, now let us verify this same determinant with any of the row. I'm taking the second row and doing the same method here. Okay, with this same matrix, as we have found the expansion of this matrix with respect to R1, and I told you that you take any of the row or column, you will get the same answer. So let us take the second column. Okay, we are taking C2 and expanding with respect to C2. Now, before that, you need to understand one working rule, that how we expand and what are the sign conventions regarding the same. So, as I told you that for the first row, we go like positive, negative, positive. So we have to go alternatively. Say for example, if it is a 3 cross 3 matrix, then plus minus plus. After positive, what comes? Negative. So negative, positive, negative. Then after negative, negative, positive, positive, negative, positive. Like this, you have to follow the working rule and the sign conventions. So with respect to second row, we are going to expand. So let us expand with respect to second row. What is this one? But as we see, this is minus, so we have to use minus sign here. Then skipping this column, sorry, and this row, we are left with 2, 3, 4, 9. So right here 2, 3, 4, 9 like this. Then positive sign, positive. Second, this is 1 times skipping this row and this column, 3, 0, 4, 9. Okay, then negative. because negative sign, this negative sign is there. So 3 times. Now what you have to do, we have to skip this row and this column. So 3023. So 3023. Okay. All right. Again, you understand we have to expand with respect to C2. Okay. Following this sign convention, what we are doing, this 1, we are writing 1 here. But as per the sign convention, it is negative. So we are writing negative. Okay. If we are taking this one, we have to skip this column and this row. So skipping this column and this row, we are getting 2349. Okay. So that is, we have written 2349. Similarly, plus minus, so plus and minus 1313, and skipping for this one, skipping this row, this column, 3049 3049. And for this one, skipping this row, 3023 Now just expand this one. We know how to expand this one. 9 twos are 18 minus 4 threes are 12 plus 1 bracket. 9 threes are 27 minus 0 minus 3. 3 threes are 9 minus 0. So minus 1 into 6 plus, this is what, 27, and this is minus of 27. They both cancelled. Answer is minus 6. So from here you have to clear one thing, that if we expand with respect to any of the row and any of the column, we get the same answer. Now let us understand the concept of minors and cofactors, which is again an important thing in this chapter, because we are going to deal with these two things mainly in the important questions. So let us understand this minors and cofactors. I'm taking one example and I'm trying to clear the idea of the minor first. Okay, minor and cofactor, they both are very much related. If you can find the minors, the cofactors can easily be found out. Okay, so let us take one example of first 2 cross 2, then we'll take 3 cross 3. Okay, A matrix 1 2 3 4. Say for example, if this is a matrix, and if you want to find the minor and cofactor, so how to find the minor and cofactor of this 2 cross 2? We denote Mij for the minors and Aij for the cofactors. All right, like this we are doing. Okay, so how to find? See, each and every element has its minor. Okay, so you have to remember this thing, that if this is the A matrix, then each and every element has a minor as well as the cofactor. In simple language, if we can understand the meaning of minor, minor means which is in downside, that means which is in inferior. Okay, so for finding the minor and cofactor of this 2 cross 2, it is very easy. How we find? First of all, M11. What do you mean by M11? This is the minor of this one. This is M12. This is M21. This is M22. So we find M11. This M11 is for this one. If you skip this one and this one, this is the downside of one. That means the inferior of one. So that is, hence this is only the minor. So M11 is equal to 4. What will be M12? Okay. If your answer is 3, then you are correct. Okay. That means 3. Minor is 3. Now for this 3, this is M21. If your answer is 2, then you are correct. Then for M22, 1 is the answer.
Okay, now let us understand the concept of the cofactor. As minor, I taught you that what do you mean by minor. Now let us understand the cofactor. First of all, just see this formula. Aij is equal to minus 1 to the power I plus j mij. Now what is I and j? I represents the row and j represents the column. in the class I told you what is I and j. If this is one position, then your I is equal to 1, j is equal to 1. If what is this position, this is 1 2 position, so your row I is equal to 1 but j is equal to 2. Okay, so using this formula we can easily find the cofactor if we know the minor. So what is the minor of this? First, see, as we have found what is m11, m11 will be 4, m12, this m12, the minor is 3, m21, this is m21 position, this is 21 position, so m21, what is m21? This is 2, and m22 is what? 4. So directly we can find a11. What will be a11? Minus 1 to the power 1 plus 1. Mij, m11 is what? 4. So minus 1 to the square 4. This is minus 1 whole square will give you 1 only. So final answer is 4. Then what is a12? What will be a12? This is minus 1 to the power 1 plus 2 into what is m12. M12 is what? 3 minus 1 whole cube into 3. This will give you minus 3. Okay, similarly m21 will be what? Minus 1 to the power 2 plus 1. This 1 is 2 cube into 2. This will give you minus of 2. And m22 will give you what? a22, which is minus 1 to the power 2 plus 2, and this is 4, so this will give you 4. So what you have to understand is the one thing, that if your power is even, then your answer will be positive, and if your power is odd, then your answer will be in the negative. This only you have to understand. See, the cofactor, this is the first cofactor is what? Positive. Why? Because on adding the positions we are getting even. 1 plus 1 is what? 2. On adding the position 1 plus 2 3, the power odd, negative. Similarly you have to understand like this.
Okay, now let us find the minor and cofactor of 3 cross 3 order matrix. I've taken one example, this one. So how to find the minor and cofactor of this 3 cross 3 matrix? As in the previous video, I've told about how to find the minor and cofactor of 2 cross 2. Okay, similarly we have to follow the working rule here also. Okay, so first, as I told that each and every element has its minor and cofactor. Similarly here, each and every element, the minor and cofactor will be there. Okay, so first let us find the minor of, this is what? This is which position? This is 1 1 position. So this will be m11. How to find the minor? See, for this one we skip this row, this column. Now we have these two, which is in 2 cross 2. That means we have to find the determinant of this matrix. How to find? 0 ones are 0, 4 ones are 4. Answer is minus 4. Now let us take this 0. This is m12. Don't multiply this 0, as I have not multiplied 1 here. Don't multiply. We are finding the minor here, not the determinant. Okay, remember this thing. The student used to do such mistakes. Okay, so don't. This is m12. Don't take this 0. Skip this row, this column. 3 1 1 0. So 3 1 1 0. All right, 0 3s are 0, minus 1 into 1 1. Your answer is minus 1. Similarly, m13 is equal to, skip this row, 3 1 1 4. So 3 1 1 4. 3 4s are 12, minus 1, you'll get 11 as the answer. Similarly, go for this one. This is what? m21. M21. Skip this row, 0 0 2 4 0. 0 zeros are 0, 4 twos are 8, minus 8. Okay, then similarly go for m22. So m22 again, skip this row, 1 2 1 2 1 0 0 minus 2 minus 2. So hence like this you have to find the minor of each and every element. Okay, now what will be the cofactor?
Okay, after understanding the concept of determinants, Okay, then secondly, the expansion of the determinant of 2 cross 2 and 3 cross 3 order, and then after understanding that, we understood minor and cofactor. Now let us have a quick glance on the properties of determinant, because by this property only we are going to solve the question further. Okay, so let us have a quick glance. So I'm taking the example and trying to make you understand what are the properties. Okay, let us take first property. Say for example, if you have a determinant delta is equal to a1 b1 c1 0 0 0 a2 b2 c2. Say for example, if this is the determinant, then the property says that if any of the row or any of the column is totally zero, as we see that this second row, this is all the values are zero, hence the value of this determinant will always be 0. This is the first property. Okay, now what is the second property? That the second property which I told you in the previous video, that if say for example you have a1 b1 c1 a2 b2 c2 and a3 b3 c3, if this is the delta, then the value of determinant remains unchanged if its row or column are interchanged, which means that the value, that means this property says that if you try to find the value of determinant with respect to any of the row or any of the column, the value remains unchanged. That means it does not changes. So if you expand with respect to r1 r2 r3 or c1 c2 c3, your value of determinant will be same. This is the second property. Okay, now understand the third property. What the third property says, that if you have a determinant like this, say for example a1 b1 c3, this is a1 b1 c1 0 b2 c2 0 0 c3. Like if you have this is what, lower triangular, this is a kind of lower triangular matrix where you have all the term here 0, then the property says the final answer you can find is multiply all the diagonal position elements, that is a1 into b1 into c3. So if you have a condition where you have a lower triangular matrix, lower triangular elements as 0 like this, then what you have to do, you have to multiply the diagonal elements like this. Similarly, the same case of this one also, if you have some certain values here and here 0 0 0 is there, then the answer will be a1 b1 into c3. This is which property? This is the third property. Okay, then comes the fourth property. Let us see the fourth property. The fourth property says that if any two matrices of a determinants are interchanged, then their value of the determinant changes by only negative sign. So let us take the example like a1 b1 c1 a2 b2 c2 a3 b3 c3. Say for example I interchanged these two rows. Okay, take that as del dash. I'm taking del dash as interchanging these two rows. These two rows I'm interchanging. So this one will be a2 b2 c2 a1 b1 c1 a3 b3 c3. Then the value of this and this will be same, but only difference will be of minus. That means your determinant will be minus of del. This is the property. If you interchange any row or any column, then the value changes by the negative sign only. This is the fourth property. Okay, let us, what does the fifth property says? That if you have two rows or two columns same, or three rows or three columns same, then the value of your determinant will be 0. Say for example, if you have a1 b1 c1 a2 b2 c2 and again same a1 b1 c1. So as we see that this one and this one, these two rows, they are same, hence the value of this determinant will be 0. Okay, this is the fifth property. So these are some important properties in the determinant. Okay, rest some more properties are there, 2-3 properties. Okay, that we will see in the question if required, but these 5 properties you have to remember and keep in mind, because we are going to use these properties in our questions. Okay, now let us take one question which is based on the property of determinant. I have written the question here. So what we have to do is, in this question we without expanding, we have to use a property and find the value of this determinant. So how we can do that? As we see that this is 43, 35, 17, this is 1, 7, 3, 6, 4, 2. So what we can do, one property says that if you have 2 columns or 2 rows same, then the value of the determinant becomes 0. Okay, see, this is somewhat a higher digit, and the second highest is this one, and this is third highest. So we can use this column, multiply some scalar quantity in this column, and try to subtract from this one. So what I'm doing, I'm using one a transformation, that is I'm transforming in C1. C1 says C1 minus, okay, 43, 6, I'm multiplying 6 5s are 30, 6 6s are 36, 6 7s are 42. Okay, 7 times of C3. That means C1 minus 7 times of C3. So let us transform in C1. 43 minus 7 into 6. 35 minus 7 into 4. 17 minus 7 into 2. 1, 7, 3, 6, 4, 2. This will remain as it is. Okay. 7 6 are 42. 43 minus 42 will give you what? 1. 35. 7 4s are 28. 35 minus 28 will give you 7. 17 minus 7 2s are 14. 17 minus 14 will give you 3. So from here, what we can conclude, that this column and this column, it becomes same on using this property, this transformation. Hence, by the property of determinant, we can directly write that the answer is 0. Okay.